Okay, so here I have Zulbetter. I'm going to do a quick compile, game, new game, have the game play, World of Zool, main entrance, go east, in the lecture theater, go west again, campus pub, go back east, there, go south, in the computing lab, go east, in the admin office, go where, floop, I don't know what you mean, quit, and out we go. So it has all of the same behaviors. What makes this better? Well, let's take a peek at the code. Our game still has a parser and a room variable. We still have to create the rooms, and the parser is going to do its thing. Well, this is interesting. Our constructor still looks the same, but setExit is actually different. So that's interesting. The interface to setExit is, has a new pattern. Play looks the same. Print welcome while not finished. Process command. Let's look at print welcome. Oh, print welcome is vastly different because now, instead of figuring out where I can go, we ask the room that we're in to get its long description, and print welcome doesn't need to know anything about exits. When we process command, help, go or quit, go room. Okay, we know that go room was a problem. Oh, go room is so much cleaner. If we don't have a second word, go where. If we do have a second word, here's the direction. Get the direction. Get the room that we're supposed to go to based on the direction. Into next room. If next room is null, there's no door. Otherwise, move to the next room and ask the current room to get its long description. This is so much cleaner. And quit. Still does its work. Okay. Not only, I said cleaner, this is so much more loosely coupled. Now, part of the reason it's loosely coupled is if we stop to think about the task of, can we go through an exit, it's really not the game's responsibility. That's the room's responsibility. Printing out or getting a string that tells us what exits are available, that's not the game's responsibility. That's the room's responsibility. So by embracing responsibility-driven design for how, making the room responsible for its data and providing methods that allow the game class to ask it for information, we now have a much more loosely coupled system and much cleaner and easier to understand game code inside of the game class. What has changed in the room? Well, we're going to use some of our collection utilities. We're going to have set and a hash map. And instead of having a bunch of room variables, we are going to have our string description and a hash map that maps a string to a room object. When we construct our room, we get the description and we make a new empty hash map. And then when we set the exit, we just give a direction and the room that that direction connects to. We put those into the hash map. And then we have a get short description where we just get the description, or we have a get long description where we return a string which is UR with the description, carriage return, and an additional exit string. And the job of the exit string is it constructs a line that says exits colon, well, no space, I'm sorry, exits colon, and then for every item that is inside of our hash map, first of all, ask our hash map for the keys, get a set of keys for every key that's in, or for every key, which is an exit inside of the keys set, we will print out that direction. Sorry, we will not print out that direction. For every key that is in that key set, we will append to the string that exit. When we're done processing all of the directions, all of the keys, all of the exits, that's all different ways of saying the same thing, we now have a string that begins exit colon and then has the exits available in a string. That gets returned up here and tacked on to the end of the description. So the room is responsible for its own data. And then when the game class was asking for a particular direction, we're just going to pass that direction into the room, and it's going to try to get it from the hash map. If the entry doesn't exist, this will return null. If it does exist, it will get the room object that exists at that direction. So I apologize for jumbling the explanation of getExitString, but I think what I do want to do is, let's go ahead and take a look at what this is doing by playing our game. And here is our debugger. And so remember, we called this from getLongDescription. So I clicked game play, game called print welcome called to the room getLongDescription. The room getLongDescription has called exitString, which gets me to here. When we execute this line, we're going to get a new local variable called returnString, and right now returnString is exits colon. Next, we are going to get a set of string values into the set keys. So we're going to ask our exits hash map for all the keys in that. And so now I have a collection of keys. Now, for each loop, grab the first key from the set, put it into the variable exit. This exit is west. Append to return string a space and exit, a space and the value west. So exits west. End of the for each loop, come back up. Is there another key inside of this set? And if so, put it into exit. And there is not. And so I step, and then I return the description, and we print that out, and I can just continue. And the reason is because I didn't create a new object. Current room was the computing admin office when I quit. So if I go ahead and keep all of these elements in place and remove this and make a new game, let's go ahead and make a new game and play. So where we were before, only now my current room, if I were to go and look at my getLongDescription or print welcome, my current room is outside the main university is the description. So this is I know that I'm in the entrance. So coming back into my stack to where I am in getExitString, step, exits, get the keys. My string exit is east, first string. Let's add that, exits east. come back up to the top of the for each loop. Is there another string in the keys list? There is at south. We'll add that to the return string. Now it's exits east south. End of the for each loop. Step, come back up. Is there another exit in the keys set? There is, it's west. We append that to return string. Exits east southwest. End of the for each loop. Come back up. Is there another exit in the keys set? There is not. We are out of the for each loop. We return this string back up to long description. We are now back up in long description. Notice we've left the method here. The long description currently has a string of outside the main entrance of the university. It's kind of a hard way to see it, isn't it? 43 characters, blah, blah, blah. 1 character each. I step. We are now outside of the room class. We're back into game print welcome because get long description has finished running, and now we can actually run and print that out. And we're inside of the play method. And if I can find my terminal window, I would see that that has come and been printed out. And there it is. You are outside the main university, exits east southwest. Okay. This leverages what we've already learned, that we can get interesting behaviors and beneficial behaviors by leveraging previously made classes such as the utility classes. It also has made for a less tightly coupled relationship between the room and the game. As a matter of fact, I can have all kinds of directions now, can't I? If I come back over here and reset, and if I go to my game class, let's say that we can also theater.setExit. If I go west, it takes me outside, but maybe if I go down, that'll take me to the lab, to the computer lab. So like I can also sort of go down the hill implicitly. And that's all I need to do because it's a hash set, and because if I try to go some direction that doesn't exist, it'll return null. But if there does exist, it knows to just map to this room. So I've made a change to the theater, the lecture theater, and if I go ahead and rerun my game and play, whoops, I'm just going to continue. Oh, I should probably take away that. You're outside the main entrance. Let me go east. I'm in the lecture theater, and I can go back west or I can go down, and now if I go down, it accepts that and it takes me and maps me into the computing lab. It's a much more elegant solution because I mean even the changes to the room class are minimal. Because now instead of having an individual reference, we have a collection that can be expanded. So we could say that, multiple directions, we could add in north, northeast, and south, south, southwest, and it wouldn't be a problem. We could, add in descriptors like you're in a room with a closet. You could say go inside. It's like, okay, you root around in the closet and you need a light to see what's in the back better. But you could make these, you can make all kinds of other descriptions in the way that you can interact with the world this way. Okay. Zool better reduces coupling. Okay, it does that by having the room class encapsulate its data. Okay, the hash map is private, but it gives, public accessors through things like get the exits or, even just get the long description. by putting the responsibility on the room class to manage its own data, it tells us A, where the data belongs and which class is responsible for reporting on it. And if you're just sort of by normal object-oriented paradigm, we say that fields should be private. If those fields are private, you're more likely to have loose coupling. Because if your fields are private, you're engaging in the process of encapsulating your data, which requires other classes to not access it directly. So with that in mind, we can talk about responsibility-driven design. Sometimes it won't be immediately clear which object is responsible for doing something. But if we keep responsibility-driven design in mind, it's like which object is responsible for having a method? Which class should get this? And the answer comes from which class has the data. Each class is responsible for manipulating its own data, and that class is now responsible for processing it. So when it comes time to produce a list of available exits, the game class could have done it and did do it, but the better solution is that it's the room class. The room knows what it's connected to. Let the room class do the work. Responsibility-driven design leads to low coupling. Now, here's the nice thing. It's like, boom, we're done. That's really simple. Ultimately, and if you embrace it, you'll get most of the most of the direction or most of the way you need to be moving towards this. However, part of what we want to worry or focus on is localizing change. So if we want to have our coupling looser and we want to focus on responsibility-driven design, a change should require changes to as few classes as possible. And right here, there was a very direct connection between game and room, but there's some other classes that have not direct coupling, but implicit coupling. It's not necessarily because of the data they're passing or the methods that are being called, but they arise from assumptions about the way the solution should be made. And so what this means is that there might be a need to split things apart when we look at the project in a little bit more detail. Think about where there's some implicit coupling in Zool better, and then, and you can also read the chapter. And when you come back, let's look at some ways to reduce this implicit coupling.